So in today's class we will study about the optical pyrometers, which is used for the measurement of temperature. First let us see the principle of operation of optical pyrometers. So the radiation from a heated body at high temperatures within the visible region of the electromagnetic spectrum. So the radiation of a heated body at high temperatures falls within the visible region of the electromagnetic system. So for a given wavelength in visible region, the energy radiated is always greater than at high temperature. Since the radiation falls within the visible region of the electromagnetic system, for a given wavelength in the visible region, the energy radiated will be higher at higher temperature. So within the visible region of a given wavelength, it has a fixed color and the energy of radiation is interpreted as the intensity or the brightness of the image. So since if we measure the brightness of the light of the given color emitted by the hot source, we can get the indication of a temperature. So we know that within the visible region, a given wavelength has a fixed color, and the energy of radiation is interpreted as the intensity or the brightness. So since if we measure the brightness of the light, of a given color, which is emitted by a hot source, we can get the indication of temperature. So here in an optical pyrometer, the wavelength of radiation accepted is restricted by means of a color filter used in the circuit, and the brightness is measured by comparing with a standard lamp. So now let us see the disappearing filament type of optical pyrometers, which is most probably used. The most commonly used disappearing filament optical pyrometers. So this disappearing filament optical pyrometer works based on the radiation from the hot body whose temperature is to be measured. So it measures the temperature radiation emitted from the hot body, and the brightness of the source and the brightness of the images are same. It measures the value of the temperature. So based on the radiation from the hot body whose temperature is to be measured, and when brightness of the source and the brightness of its image are same. So in disappearing filament optical pyrometer, we are going to measure the radiation from the hot body whose temperature is to be measured. So it has a objective lens which is placed in front of a hot body or heated source whose temperature is to be measured, and it has and in front of the objective lens we have a absorption screen, and there is a color filter which is used on the other side of the source. We will get the image of the lens here, and the glass piece is used. So the image of the hot body is viewed through this eyepiece, and in between this we are having a filament lamp, and the lamp is supplied with the help of a battery source, and the intensity of the lamp can be varied by using a variable rheostat. So by using a variable rheostat, the intensity of the lamp can be varied, and the lamp is supplied with the help of a battery source, and the current is measured with the help of an ammeter. So here we are having a heated source whose temperature is to be measured, and the radiant energy from the heated source falls on the objective lens which is placed in front of the heated source, and an absorption screen is used, and we are having a lamp and its filament. The lamp is supplied with the help of a battery whose current is measured with the help of a moving coil type meter, and the intensity of the lamp can be adjusted with the help of a variable rheostat, and we are having an eyepiece through which the image of that hot body is viewed. So this is a diagram for disappearing filament type optical pyrometers. Here the image of the radiating source is produced by the lens, and it is made to coincide with the filament of the electrical lamp. So current through the lamp filament is made variable so that the intensity of the lamp can be adjusted with the help of this rheostat. So here image of the radiating source is produced by lens, and it is made to coincide with the filament of the electric lamp, and the current through the lamp can be is made variable, that is by connecting a rheostat, so that the intensity of the lamp can be adjusted. Here the image of the radiating body is viewed through the eyepiece, and the filament is also viewed through the eyepiece through a filter. So this is the color filter. So through this filter the image of the filament is viewed, and the current through the lamp filament is adjusted until the filament and the image of the radiating body is of equal brightness. Now the filament is viewed through an eyepiece and a filter. And also the current through the lamp filament is adjusted with the help of the variable rheostat until the filament and the image are of equal brightness. So here we consider three conditions when the brightness of the image produced by the source and the filament are equal, if the brightness of the filament is high and the brightness of the filament is low. Now let us consider three conditions. The first one is when the brightness of image produced by source and filament are equal. So the brightness of the image of the hot body whose temperature is to be measured and the filament are equal, then the outline of the filament disappears. So when the brightnesses are equal, the outline of the filament when viewing through this eyepiece will get disappeared. So we'll get an image. So we'll see only the image of the hot body. The filament image will be disappeared when the source and the filament has equal brightness. And the second condition, if the temperature of the filament is higher than the source, then it becomes too bright. The image of the filament becomes too bright. So we will get an image, can view the image like this when viewed through the eyepiece. So if the filament is too bright than the source, that is the temperature of the filament is higher than the source, the filament will appear too bright when viewed through an eyepiece and the filter. And third case, if temperature of filament is lower than the source, so it becomes, that is the filament becomes dark. So the filament will appear too dark when viewed through an eyepiece if the temperature of the filament is too low compared to the temperature of the source. So the filament will appear too dark if the temperature is less. So we know that since the intensity of the light of any wavelength depends upon the temperature of the radiating body, and temperature of the filament depends on the current through the lamp. So the intensity of the light of the radiating body of any wavelength, it depends on the temperature of the radiating body. So intensity of the light depends on the temperature of the radiating body, and the temperature of the filament depends on the temperature of the filament depends on the current flowing through the lamp filament. So temperature of the filament depends on the current through the lamp. So this instrument can may be calibrated in terms of filament current, but we know that the filament current, the current through the filament in the lamp depends on the resistance of the filament. So in modern pyrometers are calibrated in terms of the resistance of the filament circuits. So the range of temperature which can be measured by using this disappearing filament type optical pyrometers is of the order of 1400 degrees Celsius can be measured by using this optical pyrometer, and the range can be extended up to 3000 degrees Celsius by using absorption screen near the lens. With the help of absorption screen near the lens, the temperature range can be extended up to 3000 degrees Celsius. And the applications of optical pyrometers. So these optical pyrometers are used for accurate measurement of temperature, can be used for the accurate measurements of temperature in furnaces, molten metals and other heated materials. So the temperature can be accurately measured with the help of this optical pyrometers. Thank you.